Let's build a rectangular tent for parking. There are 2250 cubic feet of space available. No tent is needed for the ground and the entrance. The entrance has to be a square. Determine the dimension that minimize the amount of tent used. So the amount of tent used, imagine that you have one big sheet of paper, so one big sheet of tent, and then you are trying to do folding, cutting, whatever you want, and then you want to make something that looks like this. So I want to make a tent, and then no tent for the entrance, and then no tent for the ground, so I can drive in and then park my car over there. So no base and then no door. The first step to solve optimization problem is you have to draw a big picture. Make sure your picture is nice and big, and make sure you label everything. So the picture is your first step. When you handle an optimization problem, don't expect to get a graph from a problem. Usually they will just give you a few sentences and then leave the graph to you. Okay, 99% of the time you don't get a graph. So practice. Make sure you are able to read the problem, fully interpret the problem, and then draw a graph. And of course, you have to label the graph. Okay, so what's the next step? The next step is you have to set up a primary function. Look at the problem. We want to minimize the amount of tent used. So minimize the amount of tent used. That is not regarding the space. That is regarding the tent, right? That is regarding the material. So since that is regarding the material, we are trying to minimize the what? We are trying to minimize the surface area. So the surface area, what is the surface area of this tent? So we have no door, right? So we have an x square, right? X times x, that is the x square. That gives you the area of this square. And then what else do we have? We have three sides, right? So one over here, and then one over here, and then one over there. So we have two walls and a roof. Okay, so we have two walls and a roof. So this is plus x times y, so that is one side, and then we have 3 of this, so that is 3xy. So this is your primary function. Now it's in terms of two variables, x and y, and then we have to figure out the secondary. So the secondary is they gave me 2250 cubic feet of space, so that is volume. So what is the volume of this object? So the volume is equals to, so volume is equals to the base, to the don't really want to say the base is like the area of the x of the area of the square, right, which is x square, and then you multiply by y, so that is your volume, and then this is equals to 2250 equals to x squared times y. So y is equals to 2250 divided by x squared, that is equals to y, and then I will plug in this y over here, and then we write my primary function. All right, let's do that. So your primary is not surface area anymore. So now it's s of x, that is equals to x squared plus 3x times y, so which is 2250 divided by x squared, right? So that is s of x, not s of a, s of x equals to x squared, and then you add 2250 times 3, so that is 6750. So 6750, and then x divided by x squared, that is 1 over x, or x raised to the negative 1 power. Okay, so what is next? The next step is we will have to take the derivative, right? We will have to find the absolute minimum. So let's take the derivatives. So the next step, I will just write step 3, right? And then step 4, that is finding derivative and critical number. Okay, let's take the derivative. So we have s prime of x, so that is equals to 2x. And then this is x raised to the negative 1, right? So you bring the negative 1 down, and then you have x to the negative 2. So you bring the negative 1 down. So this time we are subtracting 6750, and then x to the negative 2 is x squared in the denominator, and then you have to set that equals to 0. Okay, y derivative. Y set that equals to 0. Okay. When you take the derivative, what are you looking for? You are looking for the slope, right? So let's say we have a parabola that looks like this. You take the first derivative, set that equals to 0, and then you solve for x. X is the critical number, right? Which is this point over here. So why set that equals to 0? Because this point is the minimum. At this point, we have a horizontal tangent line. Horizontal tangent line means the slope is equals to 0. So this is a critical number. As long as you can prove decreasing, increasing, then this point is a minimum. So that's why the way we have to, the reason of finding the derivative is for analyzing the slope. The reason of setting the first derivative equals to 0 is to find the critical number, because at the critical number is either a min or a max in this problem, right? So let me go ahead and erase this because we don't need that. Okay, how do you solve for x? So first of all, let's get rid of the minus. So we have 2x equals to 6750 divided by x squared, right? And then we multiply x squared on both sides. So we have 2x to the third power equals to 6750. And then you divide both sides by 2. X to the third is 6750 divided by 2. That is equals to 3375. And then what is x equals to? X is equals to the cube root of 3375. So that is equals to 15 exactly. So x is equals to 15. This is in what? This is in a feet, right? So this is a 15 feet, and then this is my critical number. So critical number. Is this an absolute maximum? We will have to find out. So the method that I'm going to use is I'm not going to use the domain and then test the critical numbers and the endpoints. I am going to use second derivative test. So let's move on to the next step. So the next step, let's do it right over here. So this is step 5. This is finding the min or max, right? Depends on the problem. So the min or max, I will be using the second derivative test. So let's use the second derivative test. So let's take the derivative one more time. We have s prime over here. Let's take that one more time. So we have s double prime of x. That is equals to 2, right? And then this time you bring the negative 2 down. Then you have a positive, right? 6750 times 2. That is equals to 13 and then 500. 13,500, and then negative 2 minus 1 is negative 3. So you have x to the third power. And then what else do we do? Do we set that equals to 0? No, we are not finding the inflection point. So all we have to do is you plug in the critical numbers to it. So 15, you have 2 plus 13,500 divided by 15 squared. I don't care what that equals to. All I need to know is the second derivative at 15 is greater than 0. What does that mean? That means the surface area, I should say function s, is concave up at x equals to 15. Now, give me a picture. What is concave up? This is concave up, right? And then at x equals to 15, we have a horizontal tangent line, and then x equals to 15. At this point, is this a min or max? This is called an absolute minimum at x equals to 15, right? So when x is equals to 15, we have an absolute minimum. And then what is the y? So you found the x, right? So what is the y? So for the y, do you see that in green? So here is the y, right? So let's grab this over here. So this is your y, right? So to finish the job, I'm going to plug in 15 over there. So we have 2250 divided by 15 squared equals to y. So this one y is equals to 10. So y is equals to 10 feet. Okay, so let me finish this. So all you have to do is you have to submit this picture to your boss, and then the dimension is, so the dimension is x equals to 15 feet, and then y is equals to 10 feet. And then what else do we have to do? Determine the, okay, so determine the dimension. So here is the dimension. What is the surface area? The surface area is equals to, so the surface area, that is equals to x squared, right? And then plus 3xy. So you have a 15 square. and then plus 3 times 15, and then times 10. So let's see what that equals to. So you have 15 square, and then plus 3 times 15 times 10. So that is equals to 675. So this is in feet. All right, so that is the end of this problem. Do you like it? Is this helpful? If so, give me a like, share, and subscribe, and I will catch you all in the next lesson. Signing out.